Hello dear students. So let's go ahead in analysis and design tool. Today we are going to see DFD, that is also called as data flow diagrams. I am Dr. Alifia Jagirdar, Assistant Professor, Abhidananda Senior College. Do like and subscribe to the channel. Data flow diagram. It is a pictorial representation of a path which data takes from initial interaction with the system until it completes any interaction. The diagram will also describe logical data flows without dealing with the movements of any physical items. It does not detail it out. The DFD also gives insights into the data that is used in the system. It will not show the sequence of steps. The DFD only shows what the different process in a system are and what the data flows between them. It is basically going to give you answer to the four specific questions. The first is, what process makes up a system? Question mark. Second question, what data are used in each process? What data are stored? And what data enter and leave the system? Okay, so data drive business activities and can trigger events or be processed to provide information about the activity. So here IEEE defines DFD as a diagram which will depict the data source, data storage, and what processes are performed on data as nodes, and logical flow of data as link between the nodes. It is also called as bubble chart or workflow diagram. There is a prominent difference between DFD and flowchart. The flowchart will depict the flow of control between the modules, and DFD will depict the flow of data in the system at various levels. DFD will not contain any control or branch element. What are the uses? It will enable us to represent the process in the information system from the viewpoint of data. We will understand how the data is flowing from one process to another process. It is also used by system analysis to design information processing for organization. Characteristic: it is represented in hierarchical manner with required levels of details. It will focus on the process that will transform incoming data flow into outgoing data flow. DFD symbols: there are four symbols. First, a square which will define a source or a destination. Arrow, which is defines or identifies data flow, data in motion. It is a pipeline through which information flows. A circle, which is a bubble which represents a process which will transform incoming to outgoing. An open rectangle is a data store where data at rest or temporary repository of data. So there are four symbols in DFD. Now if you see this is a source and destination. So it is a rectangle. Please remember, do not try to change the symbols. It has to be rectangle. This has to be a circle. It can be an oval. So this is the process. Then these are data stored. This is your DBMS. If you're using a database, then you can use this. Okay, or you can use this as a data store. Now Gann and Sarson and Jordan, there are different types of symbols used. This is called as an external entity. Okay, here again an external entity, and if you see the process is a rectangle with the curved edges. Okay, so these are the curved edges. By Jordan, it is a simple oval. Data flow, this is a data store with an open end and two compartments, and here it is a data store completely with the two lines, parallel lines. Okay, so you can use any of these symbols. Okay, types of DFDs. Now there is a logical and physical DFD. Logical is a conceptual DFD which you are thinking, which you know the process. Okay, that is called as logical. Logically, data flow diagram means it focuses on system process. It will illustrate how your data flows in the system. It is going to use various organization for smooth running of system, like banking software system is used to describe how data is moved from one entity to another. But physical DFD is the actual implementation in the system. The data flow is actually implemented in the system, so it is more specific and close to the implementation. Let's see with an example. Now when I want to do a check encashment in the bank, So physically I know that I am a customer, I have to go to the clerk with my check. I have to get it verified from the clerk. I have to, signature has to be updated, signature has to be verified, account is to be verified, then the balance has to be checked. Okay, once it is checked, the clerk will issue me a token because I'm withdrawing an amount, okay, or either I'm depositing a check. That is all depends on you. Okay, then the clerk will send that token number to the cashier. Again, cashier will verify those things. It will check the token, check the signature. If it is correct, it will store the check and entry into the data book. The customer will come to the cashier and the cash is disbursed to the customer. Okay, this is normal. But if clerk finds something unusual, if your signature does not match, if your account number does not match, immediately the check is returned back to the customer. So if you see the arrow, it says that cashier will get the token from the customer, verify the token and verify the signature, store the check, entry in the day book, and the cash is given to the customer. This is physical. Let's talk about logical. Logically, the customer is here. Okay, so customer is going search for the customer, takes the check, customer's records are retrieved, then check with the balance and issue the token to the customer. It will check the balance from the customer account, it will retrieve the customer account, check will go here. Okay, then a token slip or check is generated. A token slip is given here. The check with the token is stored here. The store token number and checks. The check is stored here, and the token is matched here. Okay, if it is matched, the token is matched, the update will daily cash book is done, entry into the day book data store is done, and the cash is given to the customer. This is your logical DFD. This will just show the flow of data from one process to another. If you see, token slip is flown from customer to the process of search and match token. Okay, then check with the token is done and then update to the daily cache. So this is the flow of data which is shown in logical DFDs. Okay, now there are different levels of DFDs. For you all, at your level, only 3 levels are important: 0th, 1st and 2nd level. Okay, so software engineering can be, the DFDs can be drawn to represent the system at different levels of abstraction. Higher level DFDs are partitioned into low levels, hacking more information and functional elements. DFDs are numbered from 0, 1, 2 or beyond. Now there is no hard fast rule over here. You can start with 1, 2, 3 also, but the context is 0th level diagram. Okay, you will see mainly 3 levels DFD: 0 level DFD, 1 level DFD and 2 level DFD. Let's go ahead. Now what is a 0 level DFD? It is also known as fundamental system model or a context diagram, which represents the entire system into a single bubble. If you want to view your system, how it starts and how it ends, that is a single bubble will show your input and output. Okay, first thing, the system is decomposed and described as DFD with multiple bubbles. Parts of the system is represented by each bubbles and then decomposed it. This process is repeated at many levels and it is necessary until the program at hand is well understood. It is essential to preserve the number. Now this is a punchline, remember it. The number of inputs and outputs between the levels. This concept is called as leveling of DeMarco. So you have to remember, if you have one input and 2 output, then it should be same way till the end. So here, if bubble A has 2 inputs, x1 and x2 and 1 output y, then the expanded DFD that will have same exactly 2 external inputs and 1 external output. You should remember this for future studies. Let's see with an example. Here this example is result management, that is students result management. Fine. So if you see this, this is a 0th level result management. Now who all are involved? Remember that first. First is admin. I'll show you all this, one second. Who is involved? Admin, very important part. Next, who is involved? The student. Okay, then who is involved? The third is your subject entry. then your marks entry, then your reports of the student, okay, and the mark sheet. Okay, so these all people are involved. Now data entry operator is also involved, who is going to add to your databases. So now here if you see, this is the student result management. Here administrator will have an account, okay, it will maintain the user account. Data entry operator is going to enter the student information and subject information. So data entry operator is also one of the entities. Administrator is also an entity. Those who are involved into the data flow diagrams are called as entities. So this is our entities. If you see, I have drawn it with a rectangle. Okay, mark sheet generated, students information report generated. Okay, so this is an administrator. Data entry operator is going to enter the data of subject and student. Marks entry operator is going to enter the marks to it. Okay, then what I get as an output, I get a mark sheet generated, students information is generated, and students performance report is generated. So this is where the result management is done. The students detail is entered, and what I get report, I get mark sheet, and I get information of student as generations. Okay, let's go ahead. This is the next example where I am a passenger. I am going to reserve into my railways. I'm going to book a ticket. Okay, so now in passenger, before booking anything, before paying for the ticket, it is going to check the reservation. Either it is there, the ticket is available, it will pay, else it will cancel and go ahead with it. Okay, so now I have only two entities into it. One is passenger, the other is admin. And what is the process? Railway reservation. So what thing I will do? Either I will reserve a ticket or I will cancel the ticket. The railway reservation process is going to provide me ticket information, though it is a cancellation or reservation. From railway reservation, it is going to give the information to admin. Admin will get who have cancelled the ticket, who has reserved the ticket. It will also get the passenger information, and the admin is the person who is going to send down the train information, which can be accessed by the passengers as well. So this is an example of railway reservation. Next level is your online shopping system. Now here your shopping system and the customer is the only two entities which interact with each other. So the customer orders and operating an online system, shopping system is going to deliver. So this is very simple context level diagram where I have two entities. Now let's go ahead a little bit. Reservation system, I say passenger and admin. Now let's do it more in details. So first level DFD says it is decomposed. Let me change the bold point arrow. In first level DFD, context diagram is decomposed into multiple bubble processes. In this level, we'll be highlighting the main functions of the system and break down the high level process to 0th level. Now here, what are the reservation processes? Please jot down somewhere whenever you get a DFD. Okay, how do you do it? The reservation process will have two things. First, it is going to generate a ticket. Third, the reports are generated to admin. Okay, I can have a third process that is called as inquiry process, where passenger is not entering into it, it is not paying for the ticket, it is just doing a general inquiry. Okay, so now passenger either can go to a reservation process directly booking, because I just want to book the ticket and go, else I will inquire for the train, which trains are available. So your inquiry process will have down storage and up storage, means which railways coming, which railways moving out. So this is where you have all your details. Reservation process will have a reservation storage. Whenever passenger reserves a ticket, it always finds the data from reservation storage, whether that particular ticket is available or not. Then it will provide If the ticket is available, it will say ticket generation process in detail. It will go to this process and generate the ticket. Else, in any condition, whether the reservation is done or not, the report is given to the admin. So this is your first level diagram where you are going to do more of processing in details. Let's see another example. Like we had seen online shopping, only two people. What I said, customer and your shopping. But now when I do the order, when I give the order on online shopping, then there are many entities which are involved. First is the sales entry, then accounts, then stores. Okay, so this is order processing. They are going to process my order. So customer data is verified. Okay, the accounts is verifying the finance. Did I pay for it? Customer will order, go to sales department. The sales will process, go to order processing. It will verify the customer data. The customer data is verified. It will verify the finance. The amount is paid by the customer. It will go to the store and it will issue the item. Once the item is issued, the same item is given as order, sales. It is given to the sales department and then it is delivered to the customer. So if you see, this is how the data is flown. Okay, from order, process, verification to the customer, accounts, stores issuing the item and then delivering to the customer. So this is your first level DFD where I am doing it more of detailing. Okay, once an order is given, then what? So that is where the answer lies. Now it is second level DFD. So first level DFD is little bit of detailing. Second level DFD goes into more of detailing. Let's see a reservation example itself. Now we had seen the reservation process. There is a query process now. There is a cancellation process as well. As if it is a cancellation, then if it is in prescribed time, you will get the refund. If not, the whole amount is not refunded. Then after searching, if I am just searching the process, I don't want to do anything, then confirmation process is again very important. If the confirmation is not given, then it is in waiting process. If confirmation is given, ticket is generated. If waiting process is done, then ticket is generated. Okay, so let's see in detail now. This is a passenger. It will inquire for the passenger, inquire for the reservation process. Okay, so reservation is, inquiry is done, it gives back the detail to the passenger. Okay, the railway reservation is available. The passenger will communicate to the reservation process. That is, the railway department will have what? Two things: reservation details, waiting details. Then it will have cancel table. So railway department should have all the information regarding reservation, cancellation and waiting. Okay, so reservation process, the moment I say that okay, I want to book a train from Pune to Mumbai, so it is going to search the reservation. The reservation will be, the table will be provided into searching condition. Once I find out that okay, there is a seat, one seat from Pune to Mumbai, there is a confirmation process and the reservation table is updated. Like for example, my name, I have booked a ticket from Pune to Mumbai, one seat, so reservation writes yes in front of my reservation, that is status. Then my ticket is generated. It will go to ticket generation process and ticket is generated. Okay, if while searching I find out that okay, there is a train from Pune to Mumbai but I am in waiting process, then my name is written into this process which is called as waiting process and the table is called as waiting. Once the waiting becomes confirmation, ticket is generated into ticket process, generation process, and it is generated with ticket. Now instead of searching, I want to cancel my ticket. So again there is a process called as cancellation process and it will update my cancel table, and this cancel table data is again given back to railway table, because then the railway department will update the reservation process. So cancellation process, again ticket generation process is there, ticket is generated, whether it writes as cancellation as ticket or cancellation. So there is again a query process where reservation process queries for reports and reservation. Okay, so this is called as second level DFD, where waiting table is a database, cancel table, generate report, reservation is a database. Okay, so waiting is again database, reservation is database. So this is called as databases. Next is user account maintenance. Now here, like student result management system, we have seen here what user account maintenance, display user account info and validate your process, that is user info. So here administrator is responsible for uploading and updating your details. So here if you see, administrator is going to enter or update, delete user information, that is validate user information, access user info, it will display user account info. Okay, and these two things are retrieved from user account number, user info, and update or delete user info. This is first part. Next is login. So login is again data entry operator will enter the user ID, password and role to it. Marks entry will enter the user ID, password and role, that is marks entry, and administrator will write its own role. Okay, coordinator will enter user ID and role, and this all things, the user information is recorded through an account called as user account info. Okay, then student information management, here it will display student info or validate the process. So data entry operator is going to update, delete the user info, it is going to give the access to the user info, and this all can be retrieved from the student info, that is display student information, it is going to take the data from this database. So this is student information management. Here if you see subject information management, I am just writing in more detail with the first level DFD. Student information, again data entry operator, retrieve information of student and update. These are the process, display and validate. Then student subject choice management, data entry operator, then this is display subject choice, student details and validate the process. Next is marks information management, it is going to display the marks and then validate the process. Same marks entry and the student performance report is generated. Student subject details is taken from the database, student subject information taken from the database, and student information. So this is going to validate and process the marks information. So marks sheet is generated and the student's report is generated. What are the advantages? It is going to help us to understand the functions and the limits of a system. It is a graphical representation which is very easy to understand and visualize. It represents detailed and well explained diagram of system component and is part of system documentation file. DFDs can be understood by both technical and non-technical person because it is very easy to understand. Disadvantages: at times of DFD can confuse the programmers regarding the system. Like before slide, if you see, there is lot many DFDs and it becomes very confusing with the arrows. Data flow diagram takes long time to generate, and many times due to this reason analysts are denied permission to work on. So it takes long time, DFDs. Logical versus DFDs. Physical DFD. Logical DFD depicts how the business operates. Okay, how. And the process represents the business activities. The data stores represent the collection of data regardless of how the data is stored. It's how business is controlled. And physical DFD is how the system is implemented. Okay, how the current system operates. The process will represent the program modules and manual procedures. The data store will represent physical files, databases and manual files, and it will show how the controls for validating input data, obtaining record, for ensuring successful completion, and for security system. Creating data flow diagram, these are few steps which you should keep in mind. You should first create the list of activities to the corner of your paper. Then construct context level DFD, which is nothing but your complete system, overview of a system. Then construct level 0 DFD, that is manageable sub-process, then first level, and then again check all the rules of DFD. So you keep on deriving your DFD, but you should also keep on checking with the rules of DFD. Thank you so much for watching my video. In the next session, we'll be practicing one of the practical of DFDs. Thank you so much.